Buonasera, good evening. First of all, I have to say my big thank you to Professor Antonio Varcasia and Dr. Claudia Tamponi for their hospitality and their willingness to invite me here in Sassari, in University of Sassari, so I can learn the group some things which I've learned many years ago or sometimes ago. But I have to say that I am a man who wake up quite early, 5:30, around 6 o'clock, and start to work at home in Košice in 6:30, 6:45. So my brainstorming is something between 7 o'clock until 12, 1, 2, 3, you know. In the evening, I am not just doing something in my garden, but nothing serious in scientific way. Okay, so just excuse me if my English brainstorming will be not so optimal, okay? So we can continue. So first of all, I have to present myself. I'm working in Institute of Parasitology in Slovak Academy of Sciences, which is the institute which belongs, as I said, to Slovak Academy of Sciences, which is not a university, which is covers more than 40 different scientific institutions in Slovakia. And it's not only biological, with biological orientation, but it's also mathematical, history, and physical, and so on. So we are situated in Košice. It's about more than 50 employers. And so currently I'm working like director of this institute. So what I will be talking about today. So my today's agenda will be firstly a little bit very briefly about anthelmintics. Then I will skip to anthelmintic resistance, and then to management of anthelmintic resistance and alternatives for the control of the parasites. In the last two parts, I will show also some data and some results from our research experiments during the last more or less 10 years. Okay, so now I'm stepping to the chapter 1, which is anthelmintics. And of course, I know that this is not the lecture for students, so I will be quite briefly and do some slides quite quickly. So most of you knows, or everybody knows, that anthelmintics are drugs that are used to treat the parasitic infection. And it's not only nematodes, it's trematodes, it's cestodes, and so on. And we can skip to the human parasite. WHO estimates that currently approximately 2 billion of people harbor parasitic worm infections. So, and as I said at the beginning, it's not only affected the livestock, but also the crops, and it's also it's affecting the food production and resulted in some economical impact. But maybe some from you know, some don't. The drugs which was available for human treatment were first developed as a veterinary medicine. You know, so it's quite strange. The question why it was like this, because the nation which suffer most from the tropical parasitological diseases, which is of course mostly Asia and Africa, have a little impact and have no money to invest to drug discovery or therapy. So that was why it was the first veterinary medicine and subsequently medicine for human treatment. So most of you know that we are separated the anthelmintics to the classes. And we know the narrow spectrum anthelmintics, broad spectrum anthelmintics. So basically in veterinary medicine, we know 3 classes of broad spectrum anthelmintic, which have been used for more than 50 years. So now I will go and summarize very briefly these 3 groups. First is the benzimidazoles. which was discovered in 1961. It was thiabendazole. And from this time, many of the benzimidazoles have been developed and still used. For example, in Slovakia, I know also in Italy, in Sardinia, still using albendazole or fenbendazole. So it was the first group. I will not mention about mode of action or these things, which is, of course, not the lecture for students, as I said. The second group is tetrahydropyrimidines, which is most famous is levamisole, was also established and found in the 60s, 1966. Also the pyrantel, it's a second group, it's a different mode of action comparing to the benzimidazoles. And currently are not very often used in worldwide, but still have some explanation why in some countries still using this type of the group, this class. So the most common anthelmintics currently in the world, it's macrocyclic lactones, which is two groups, avermectins and milbemycins. And so it's, you know, that it's a product of the microorganism which is belonging to genus Streptomyces. And it's not only ivermectin, but also abamectin, doramectin, eprinomectin, and selamectin, which belongs to the avermectins, and milbemycins is well-known moxidectin. You know, this group, it was established in 1983, like ivermectin, and it was very most common all over the world for the treatment of parasitic infections, not only in domestic animals, but mostly in domestic animals. So the new classes of anthelmintics, it's not really new because it was established in 10, 15 years ago. First, it's using just in pets, in cats and dogs, and second one, AAD class, which is monepantel, which is also using, for example, like 12 years. It's a bit expensive if I am comparing the price in Slovakia. Farmers are not using this monepantel because it's really expensive. It's registered in many countries, mostly the farmers used in Australia or in New Zealand, but also in Europe. So the next chapter, is resistance to anthelmintics. So I will start with a very general picture slide with Isaac Newton, which lived in 16th, 17th centuries. And this famous physician, he was found several different physics law. One of these was the law of action and reaction, which is telling us that for every action force, there is an equal and opposite reaction force. So then if we're talking about action, so it's a drug therapy treatment. And if we're talking about reaction, so it's development of resistance. So this is just simple comparing to some physical law. But of course, if you treat something like parasites, so they behave, they try to make a defense, they try to develop some reactions against this, and this is resistance. So these graphs show you that in the bottom you can find the different drugs. And it's not only anthelmintics, you can see benzimidazole, levamisole, ivermectin, and monepantel, but also a few antibiotics, insecticides, and fungicides. So it's a development of resistance to this drug. So it's, if you look on the bottom of the lines, so there is the information in which year the drug was entered to the market. Okay, so you can see the upper side of the lines, it's where appear first cases of anthelmintic resistance, or not only anthelmintic resistance, but also the resistance to all these drugs. And you can see, if you look good, that the time between the entering these drug to the market and first cases of resistance is usually around 10 years. If you look most closely to the anthelmintics, which is, for example, benzimidazoles, which it's something like 7-8 years. The same levamisole, ivermectin, it's maybe something like 12 years. Monepantel is just 2-3 years. Monepantel, as I said, was introduced something like 12 years ago, and suddenly after 2 years using, it was confirmed resistance to monepantel to Trichostrongylus species in New Zealand. So if we are looking on this graph, so why we are surprising? Why we are surprising that the anthelmintic resistance exists? Resistance exists to everything, you know, to everything which started to use against bacteria, against insects, against fungi, and also the anthelmintics. So I just write his like our future. This is a paper which was published in April 2024, and its situation in Sao Paulo. It's a state from Brazil, and it's about sheep farms and prevalence of anthelmintic resistance. So if you can see here, I will read a little bit. The mean efficacy of albendazole was 40% in the farms, tested farms. Only in 2 farms, levamisole, so it's another group, presented a relatively high percentage of reduction in the fecal echo reduction test, about 90%, while ivermectin and moxidectin presented the worst mean efficacy, 34 and 21% among all farms. Like other anthelmintics, closantel demonstrated low efficacy, 63%, and then finally monepantel presented an overall mean efficacy 79%, but it was the only anthelmintic that presented efficacy more than 95% in 5 farms, which means that in this state, in the sheep farms, its situation, it's terrible. You know, in some farms, now I'm not talking majority, but some farms, they don't have a active anthelmintics. They don't know what to treat these farms because the resistance it's I don't know, there is no information here, but it's probably mostly Haemonchus contortus, and it's resistance to everything. I'm not telling that this is our future, but some countries looks very similar. So what is the situation in the prevalence in Slovakia? In the Institute of Parasitology, we did several surveys. The first, I'm start to prevalence in sheep farms, started 30 years ago. We did the first study when benzimidazole resistance it was at that time approximately 7% of farms had benzimidazole resistance. 10 years later, it was more or less the same situation, 9% of benzimidazole resistance. So, and then 10 years later, more or less, it was still benzimidazole around 10% and starting macrocyclic lactone, namely ivermectin, also with a 10%. So I would tell this situation, it's very optimistic and very good for Slovak sheep farms. We tested in some surveys more than 100 farms in all the territory of Slovakia. So the situation with the goats, it's quite different because first, also 30 years ago, we did the first study and we found no resistance to benzimidazole drug in this prevalence study. But then after 20 years, it was already 86% of the farm have benzimidazole resistance, and the new data which comes from last year and this year, it was about 30% resistance to macrocyclic lactones, mostly eprinomectin, but also some to ivermectin. Okay, so situation in the goats in Slovakia, it's quite different comparing the situation in a sheep farms. We also tested the cytostome in horses, and at that time, so it's a quite a long time ago, more than 20 years, it was more than half percentage, 55% of the farms have a resistance cytostomes to benzimidazoles. So we are shortly moving to the management of anthelmintic resistance, which is very important. Now I just until now I just summarized, you know, the situation. What is the situation, and what now we are going to the step where we are going to tell what is the solution. So the main question is which we need to be answered is if we are able to prevent the emergence of anthelmintic resistance, because this is the very crucial question. I remember when I was a student, and when I was PhD student, it was 1989, so it's many years ago. The situation with the anthelmintic resistance, because my PhD study was about anthelmintic resistance. So I studied this topic. And so, you know, it was real different if we are looking back to the 35 years ago. You know, the situation now is worse and worse, and I will tell why. So the main selection factor for developing of anthelmintic resistance is a treatment. But we know that a total anthelmintic, it leads us to the total anthelmintic failure and occurrence of polyresistant parasite. Now I had idea to talk a little bit about one country in Asia, it's Malaysia. And the government in 80s, last century, they defined that they start to breed the sheep, and they invest a lot to set up approximately 100 sheep farms in all of the territory of Malaysia, you know. But soon, which means that after 10, 15 years after they started, they have extremely high death, especially young animals, lambs, in a pasture. You know why? Because somebody forgot that in Malaysia it's extremely good conditions. I mean temperature, humidity, and all things for developing larvae on a pasture. So Haemonchus contortus was developed to multi-resistant, and so soon after these 15 years, they start to close the farms, and after 20-25 years approximately, they closed almost all the farms with the sheep breeding in Malaysia because it was not possible, because it was the young, especially young animals, but not only young animals, died in a pasture because it was Haemonchus was everywhere and it was multi-resistant Haemonchus, so there was no drug to treat them. Right? So it was the story about Malaysia. So especially veterinarians are using the traditional wisdom that treat everything on the farm and treat often. What does it mean? I'm telling that if you comparing the situation in a medical doctor, which opened the waiting room, and it's there be something like 20 patients waiting for some drug. So doctor will say, I will treat all of you with antibiotics. This is prophylactic treatment. This is what veterinarians doing in a farm. They are not selecting the animals. Those who really need the treatment, they just treat all heads on a flock. So this is prophylactic treatment. But of course, this short-sighted approach ended up with leaving us with no effective treatments, as I said, the example of Malaysia, or for example, almost in Brazil. And it's not only Brazil, it's almost whole territory of South America. Of course, for the most part, no new drugs are in the pipeline. I said the case of Monepantel, which is starting resistant very soon after not only 10 years, but just 2 years. And of course, everything is about the money, and it costs a lot to develop a new drug. So we have to formulate new goals. New goals, it's just minimize drug use and use the drugs therapeutically instead of for prophylaxis. But of course, it's not so easy, as I said. This requires us to monitor the animals in some fashion to identify animals in need of the treatment. I will tell a little bit later about this, but it's very difficult. Because we need to develop a strong refugia of sensitive worms to overlap the fight with the resistant refugia, So there are two different refugia, mostly in a pasture. So how we can identify animals to treat? Of course, generally there are several methods. First of all, that is quantitative fecal accounts. It's fecal accounts, which is, of course, expensive. In some country, it costs 2-3 euro. In some country, 9 euro, 10 euro per one head. So if you have 400 heads in your flock, so it's 400 by 4. So it's 1,600 just for evaluation. What is your parasitostatus of your animals? Then another steps is to do fecal consistency or body conditions. It's not very good for choice for a Haemonchus, but for Haemonchus you can do the pharmacia, which is identification of anemic animals. It's not very helpful for some countries like Slovakia, for example, also Sardinia. It's very good, for example, in South Africa, where they adopted this. It's very good, for example, in some countries where the most prevalent and resistant worms is Haemonchus contortus. In Slovakia, which I named the Slovakia, we have Haemonchus there. It's approximate 20-25% of farms, they have a Haemonchus, but majority is Ostertagia trichostrongylus. And probably is the same in Sardinia, as I've heard. So these recommendation, which could prevent the emergence of resistance, it's very old. When I was, as I said, students, it was published at that time, and everybody repeating this and again, and I will repeat also again this one. But from the respect of developing a resistance, it changed a lot. It's increased dramatically. So people or farmers are not respecting this, or the explanation is in some different things. So use the appropriate dose. What does it mean? It's recommended therapeutic dose, which could eliminate also the heterozygous worm population, which means that it's still better a little bit to put to the animals 10%, 15% overdose than to use the subtherapeutic dose. Of course, weighing, it's not just estimating the weight, it's just weight the heaviest animal. But it's very, as I said, it's more than 30 years, 35 years old recommendation. I think most or all veterinarians should know this. So then it's also the frequency of anthelmintic administration. So, of course, the frequency of anthelmintic treatment has very close correlation between the development of resistance. It was published some time ago that to develop benzimidazole resistance, it needs 9 generations. So 9 generations of parasites should change, successive generations should change, and each of these generations should be in contact with the anthelmintic, benzimidazole anthelmintic, then starts the genetic change, and the parasites are resistant to benzimidazoles. Of course, the frequency of treatment in Slovakia, it's in majority of countries, it's 2-3 times per year, but usually 2 times. Majority of the farmers use 2 times. But reports from some countries with a very high occurrence of resistance, it's 5 to 15 times per year. You know, the question is why these people are using so often the anthelmintic. It's because they need it, the animals need it, because its situation is high EPG, and they really need because it's clinical resistance, or it's just that that pharmaceutical company are pressing the farmers to use these drugs as often as possible. I don't know. But it's not the situation in Slovakia, these 5-15 treatments. Of course, the frequent anthelmintic rotation, you know, so it's you can of course rotate. It's not good if you are staying with one drug, with one benzimidazole or ivermectin or macrocycline group many years. It's still the best to change this. For example, and rotate the anthelmintics. So for example, benzimidazole, second group tetrahydropyrimidines, or ivermectin. There is also a slow rotation, a rapid rotation, which is a difference if you are changing within 1 year or year by year. But still, to change anthelmintics in the same year, for example, in Slovakia, it's the habit that in the spring they use the benzimidazoles, in autumn, after the finishing of pasture season, they use the ivermectin. So it's a general habit in Slovak sheep farms. So then it's another appropriate farm management methods. As I said, let's say 30 years ago, nobody talked about these farm management methods. Of course, it's very scientific farm management method. But what does it mean in fact? It's just simple rotation of the pasture and low intensity farming, sheep pen rotation. Or, of course, you can rotate from year to year different animals like cattle or sheep. And of course, separate the sheep and goat breeding, because the sheep and goats developing of resistance is not the same. It's much faster in goats, which I showed also in a case of Slovakia, where we have quite different picture. So what does it mean, breeding intensification? It's just simple number of animals, number of heads, concentration of animals on a pasture, for example, per hectare. Of course, very important is pasture size. If the pasture are fenced or unfenced, and a pasture rotation during grazing season. Because why I'm talking this, it's just simple things, but parasitostatus of animals, so it's the EPG of the animals in average, is very closely related with the number of infective larvae. And these are very, of course, correlated with the reinfection. And if you're putting the drug selective pressure to this circle, to this gap, so then the resistance is developing faster. Now I put a nice picture I found somewhere. It's not probably in Slovakia, but this intensity, it's many of the sheep which are on this pasture. But this intensity, you can, I'm not sure if it's a permanent pasture or if they rotate or whatever. But in this kind of the pasture, you will receive the resistance much sooner. Why? Because its breeding intensification is very high, you know. then you have a problem with parasite, then you have to treat. If you are treating, then you have a soon resistance. It's simple, you know, so it's not, you don't need a scientific degree to this to understand. Now, these are our data, which we, if you see this, all the red lines. This is farm 1 and farm 3. And on the left side, on the left, you can see the EPG. On the bottom, it's a month. So it's a pasture season of Slovakia. It's a mean average of EPG. I think it was around 50 animals, which we can monitor during all pasture season, which is in Slovakia, usually from April until end of October, beginning of November. So we monitor all these animals, and this is a mean. The same, you not follow the Botcon or DISCO index, but just the red lines, okay? If you compare these two farms, so you can see that in the end of the pasture season, which is in Slovakia, is the highest, let's say, fecal accounts in average in animals. In the first farm, it's something like 130. In a second farm, farm number 3, it's more than 700. The difference between these two farms was that the farm 3 was the permanent pasture. They kept the animals during all pasture season in a one pasture. Opposite to the farm 1, they change a pasture. As I remember, 3 times. So that's the point, that there is a risk for infection and reinfection in farm number 1. It's much slower compared to the permanent pasture. Then if you're putting to these Anthelmintics, you have situation, it's simple, and during several years, you have worms which is resistant to drug. So another thing is that you can follow all the recommendations which I just mentioned, but then you can import resistant parasites also within the herds, within the country. Not only within the country, but within the import. You can import animals from abroad. For example, we have a situation in many years ago, it was more than 30 years ago, in 1993, I was PhD student at that time. And in Slovakia, we imported the goats from New Zealand. And it was, in 1993, it was multi-resistant Ostertagia species, because there was several species of Ostertagia. And it was resistant to benzimidazoles and ivermectin, and also to second group. You know, it was at that time, 30 years ago, at that time, we didn't know that these multi-resistant species exist, because it was not published at that time. So we put the animals to the quarantine and tried to effect deworming. Of course, we combined with the higher dose of albendazole 4 times, combining with the levamisole, and combined also with the ivermectin. Of course, it was a little bit risk that some animals die, but unfortunately, it was not happened at that time. And we treat this at that time. So, as I said, the farmers could follow all these recommendations, but they one day received a few animals from a different farm with the resistant individuals, with the resistant parasites inside of the host. And this could spread resistant worms to everyone, or multi-resistant. So be aware also of these things. So of course, efficient monitoring and regular examination for the presence of resistant strains is also important. How you can do it? You can do the fecal account reduction test, which is not difficult, but many farmers is not doing, of course, because you need a microscope and all these things. It's also some expensive. And then it's another way, it's to do in vitro test. But this test is just for specialized institutions. We are doing this test many years, more than 30 years, definitely. And then, because the selecting suitable anthelmintics is very important, because inefficient anthelmintics is ineffective investment. So, for example, take this example from the São Paulo, from the Brazil. You know, majority of the money, it was lost because the effectivity of the almost all anthelmintics was sometimes 20, sometimes 40, sometimes 60. But we expect, of course, more than 95, 98%. So what can you do? What can you do? Then you can still use the drugs with a different mode of action, as I said. The farmers or veterinarians will not follow these recommendations. So, for example, not to use benzimidazole because you have benzimidazole resistance, use ivermectin. But if you will not follow this recommendation, it's just a temporary effect and emerging resistance to a new drug. Of course, you can still use a narrow spectrum anthelmintics like rafoxanide and closantel. But you see the picture from Brazil, it's also in this narrow spectrum anthelmintics, there is a developed resistance. So it's a temporary effect. You have to change something else, not only the drugs. So you can use 2, 3, 4 drugs with a different mode of action. These apply mainly in Australia and New Zealand. They use these 2, maybe 3 drugs merged together. But soon, if they didn't change anything, they change just these drugs, which was combining together. And soon they have also the resistance to these double or triple anthelmintics. As I said, it's temporary solution to the problem. So what can you do else? So you can also increase the drug efficacy through its better accessibility in the organism. What I'm talking about. So you can slightly affect the pharmacokinetics of the drug in the body. This attitude, either diet modification or dividing the therapeutic doses, it's helpful, and it was published in Australia by Des Hennessy. And it helped, but only when you have resistance, increased resistance to susceptibility, 15, 20, 25%. So if you have a resistance to benzimidazole, for example, or ivermectin, 70, 60, 80%, so it's increased 15, 20%, not more. But if you have a resistance like 3% of efficacy, 5, 10, 15, so it's useless. What I'm talking about, so you are just increasing the killing zone. This is a concentration of drug. If you diet modification that your animals is starving before it's starving, just 12 hours before the treatment. And then if drug is associated with the particles of digesta, so digesta is slowing, moving of digesta is slowing, and then anthelmintics, it's a longer time in a digestive tract, and it's longer time affecting the parasites, which finally gives you results of 15, 20, 25% higher. The same effect if you divide the doses, for example, double dose, don't do it double dose. Double dose is just that peak is going up and then very fast down. But this killing zone, it's with the double dose, it's the same, like with the single dose. But if you put this one single dose and then after 12 hours another one, so then you will prolong this killing zone, let's say half, which results to the increase of efficacy. So this was published also in 90s or 2000, something like this. But I'm not, I think the farmers in Australia, some they used, but I'm not think if the farmers in Europe, it's using, but it worked. We tested this and it worked. Okay. So dilute the resistant population on pasture or in the host. As I said in the beginning, I mentioned refugia, which is the part of the parasite population which is not exposed to Anthelmintics. Mostly it's infective larvae on the pasture or parasite present in untreated hosts. You know, so it's a very last 15, 20 years, almost everybody using these refugia, you know, just to compare and overbalance sensitive and resistant refugia. But the output is decreased number of animals treated with anthelmintic drug. So in this way, you should apply targeted selective treatment. As I said in the beginning, the intensity of infection in a host, I'm talking about the parasite, is over-dispersed. In a few animals, it's a very high EPG. In some of them, it's intermediate, let's say, I don't know, 40%, but the rest, it's almost without parasite. So you should identify just those with the high EPG, because these females of the parasite in these animals are spreading the eggs to the pasture, and you should identify those animals. So how can you do it? As I said, we try all these methods during the one European parasol project. It was the BotCon. You can classify the nutritional status of the animals. It's a sheep or there is a sheep. You can select the treatment based on DISCO index. And I could tell you that none of these two is very helpful. We found very helpful, and not only my group found very helpful, apply the selected treatment based on the changes in the weight gains. And this is also just in lambs, in young animals, which are growing. Those who are have a very low weight gains, so you applied treatment. And in this way, you can minimize the treatment. Because what we are talking about the minimizing of the treatment, because treatment is a main factor for developing resistance. So finally, it's last part, which I will talk mostly from our experience with the alternatives for the control of parasites. There were several groups which was studying the effect of fungi treatment, because the mycelium could reduce the concentration of infective larvae on a pasture. You can see the nice picture. You can see the mycelium which was trapped the infective larvae on a pasture. The most promising at that time, I'm talking about 15, 20 years ago, situation, it was Daddingtonia flagrans. It worked, but the problem is that which pharmaceutical company will produce this idea, because it's expensive, you know. It works. You are not expect the reduction like 100%. It works. Then nutrition treatment. Maybe some of you know that if you increase the protein intake, it may decrease the worm burden, and it's just because mostly in animals which are in stress or immunocompromised animals. And several studies also shown a link with the phosphorus, cobalt, copper, I'm just namely Cooper oxide white particles in the United States, zinc, selenium, and molybdenum. Okay, we tested zinc and selenium, and they affect how to reduce parasite infection in animals, in lambs. So another attitude is to use the condensed tannin treatment, which all this experimental works. Also, several groups in the world has been dealing with this problem, and some forages with the high contents of tannins may lower fecal counts, and also the worm burdens. I put some of them, but it's not, of course, it's so many of them. But everybody from this group which work with this telling you that do not expect the high reduction. Usually it's up to 50% in fecal counts. So if you are using this attitude and using to treat the parasite infection with the herbs which are rich for condensed tannin. So during the last 10 years, we used and test the herbal treatment. It was just alone, some herbs, and also with a mixture to the experimental infection of Haemonchus contortus in lambs. So the first experiment, it was Malva sylvestris and Artemisia absinthium. So it was the herbs which was added to the concentrate of the lambs within these days. You can see that the reduction in the first case in Artemisia, it was just around 7%. In a group with the Malva, it was just 16%. With the combination of these two, there was no reduction. And in abomasum, we found just 12% of reduction. So it was not really succeed, but showing some direction. If you follow the graphs, so you can see that the Haemonchus contortus has a production period reaching something. Here it's from topping with day 50, and then it's lasting. Of course, we finish in day 75, but usually it's more than sometimes it's more than 100. So the highest EPG you can see here, it's something like the red. The red is the control. The red is the control. So it's 20,000-30,000. So it's quite high EPG, which is lasting in these animals. Okay, so this was Malva sylvestris and Artemisia absinthium, and combination of these two. Next year, we compare another experiment that we use the Cellplex, which is selenium, which was added to the concentrate of these lambs, one group, which is blue one. And then another group, it's a herb mix, which is the mix of the 9, that year it was 9 medicinal herbs, which is very typical for Slovakia, not only Slovakia, but Central Europe. It was dry, and it was offered every day in some low level to the concentrate to these lambs. And what we can see that the fecal count reduction on day 119 at the Cellplex selenium group was 53%, and herb mix the same 53%. Reduction in adults in abomasum in a selenium group, it was 51%, and herbs 36%. So you can see that these are a little bit more optimistic result than we had the previous. You can see that the infection we stopped in day 119, and in the control, which is the red, it was very high. Here it's up to 20,000. It's variated, but it's from 15, 12,000 up to 20,000. So even in this very 119 days after infection, the control group keep very high infection. And you can see that we find reduction in this day. There was mostly no reduction if you compare herb mix and control up to day 84. But in a selenium, it was reduction if you compare the red and blue, already starting with 28. Finally, it ended up together, this selenium and this herb mix, but with the herb mix take longer time. And we can just make a hypothesis that it's a direct effect and indirect effect, immunocompetency and so on. So this was another two. Yeah, this is another experiment when we compare the Onobrachys vicifolia, which is sunfoin pellets, which was giving to one group of the lambs, comparing with the control. Control is a rat. And the same, the fecal account reduction, it was something on day 44 because it was quite fast effect. It was 36%, and in abomasum, in a dissection, it was 30%. But it was quite fast, direct effect, because of course the sunfoin pellets are quite rich for condensed tannin. So it was not necessary to wait 120 days like the previous experiment, but we just stop this in day 44. So another experiment which was done last year in 2023, the previous experiment, but everything was the indoor experiment. This, we started the outdoor experiment in the experimental pasture, which was never exposed to the pasture for animals, never. And in one part, we see the chicory. Chicory is Cichorium intybus, is very well known because it's very high content of condensed tannin. And we want to test the effect of this chicory compared to the control groups. So we have two groups which was separated by electric fence and so on and so on. So, but we kept the infection until day 145, and we received these kind of results. Unexpectedly, it was both reduction, not only in a chicory group, but also in a control group. So now currently we are putting all this stuff together and trying to explain why. I don't want to speculate about this, but this was the pasture which was first time using like pasture. It was not a pasture, it was meadow, something like meadow, and contains many of the flowers, up to 80 different flowers, both groups, both control groups and chicory. Because you can see that decreasing of fecal account started in day 35, so quickly. And then after day 145, that was almost completely eliminated. You know, so it was like almost zero. In some animals, was some animals, because it was 10 animals per group. In some animals was zero, nothing, you know. In some animals, just few hemonchus. So if you remember the red lines with the previous experiment, in a control groups, it lasted 20,000 up to end of 120, 140. This is something different, which we did not expect it, but it's of course, this is science. So we decided to repeat this kind of experiment also this year. We finishing just 1 month ago. We received similar picture, and we tested also the chicory, because chicory is 2 years. So it was also growing this year. We test yellow, it's a zinc, nano zinc, and with also the control group. Similar feature like last year, the fecal accounts start to diminish, and fall down in already day 28. First, zinc group, then chicory group, and also a control group, but it was not to zero or close to zero. It was just control group was something between 4,000, 3,000, and 5,000. Whereas the both groups with the zinc and with the chicory was ended up with almost majority of animals was zero. So this is just the results from this year. We have to also explain this. I have to say that I'm working, as I said in the beginning, 35 years in parasitology, but I never said such kind of dropping EPG in a control group, because we are talking about, it's not only zinc effect, it's not only chicory effect, it's something else which also give some effect to the control, like in previous. So we have to set up a new experiment and new, and hopefully we will go and we will try to explain this phenomenon, because as I said, I haven't seen in 35 years so rapid decrease of EPG in groups of the animals. Okay. So as I said in the beginning, this is my almost last slide. Situation in anthelmintic resistance is constantly worsening. And we are still relying on the new anthelmintics with the new mode of action. And proposed solution can be effective only in a co-action with the farmers and accepting the increased cost, because it's every time increased cost associated with the treatment. So the main goal of this presentation was not to confuse, but to show that if the farmer, veterinarians, everybody choose the wrong attitude, then it may affect the whole story. So I think it was the last one. Okay. So thank you very much for this presentation. And I have to say also, thank you very much to University of Sassari, which offered me some professorship to stay here just 12 days and learn your group how to manage with detection methods for anthelmintic resistance. Thank you very much.
Allora, eccoci qua. Allora, io ho scritto, innanzitutto mi scuso perché abbiamo avuto degli inconvenienti tecnici, perché c'era prima un ritorno e poi anche se mi hanno detto che di fatto poi si è stabilizzato. Allora, ci sono delle domande, chi vuole può scriverla nella chat, e qua in sala abbiamo sicuramente delle domande. E lo stesso per quanto riguarda YouTube, magari se guardate me ne fate sapere. Intanto il professor Scala voleva fare una domanda per il relatore. Ve lo dica in italiano poi.
Intanto volevo ringraziare e complimentarmi per la relazione del professor che diciamo è stata, non è facile in un'ora cercare di dare diciamo delle notizie complete su questo fenomeno molto difficile da gestire e anche da capire. Lei mi ha dato alcuni input importanti per quanto riguarda appunto l'antiemetico resistenza. In particolare, io volevo capire qual era la sua esperienza e il suo suggerimento per quanto riguarda l'applicazione di alcuni parametri per i trattamenti selettivi, e mi riferisco al body condition score e allo score della diarrea. Lei pensa che possano diventare davvero in pratica diciamo, un parametro da prendere in considerazione o no? Perché i risultati sono un po' altalenanti, diciamo.
Okay, Marian, a brief recap. Professor Scala, first congrats you for your presentation, and then ask if diarrhea and body condition score could be two markers for evaluating selective treatments on sheep. And what do you think about selective treatments, if are applicable or not?
Thank you very much for the questions. We tested this. And, as I said in my presentation, it was some time ago, as I said, within the Parasol project, but not only our group tested. It was several labs from the different countries which tested the body condition score and diarrhea index. The conclusion is that it's not only conclusion from Košice, but the conclusion from all of the countries that it's not very helpful parameters, because could be some different points which is involved in a parasitic infection compared to the body condition score and diarrhea index. If, as I showed, different situation is to measuring weight gains. It's very nicely, and it's not only our conclusion, but only conclusion of all these laboratories, or majority of these laboratories. It's weight gains or decreasing of weight gains in lambs. It's very nicely correlated with the high EPG of these animals, of these lambs. So you can easily weight animals and then compare how was the weight gains during the last time, for example, 1 month or 1 week, and then if it's low, so just treat or not treat if the weight gains are average or high, you know. So weight gains, I guess it's easily, not easily, but it's applicable to this targeted selected treatment, but not body condition score and diarrhea index. It's not correlated. You know, I show some graphs. You have EPG there, and you have also body condition score in these animals, and you have also a diarrhea index. There was not really correlation. It was not our conclusion, also our, but the rest. So it's difficult, you know. So.
Farwa, if you wanted to make your questions, you can go live.
Hi, Marian. I am Vincenzo. I stay with
Ciao,
Farwa.
Vincenzo.
Buonasera.
Buonasera.
Ciao, Marian. So just a practical aspect, Marian. In the selective treatment is really easy to perform it in horses, where we can make the fecal egg count individually. In your opinion, it is possible to make the fecal egg count for groups and category of animals, and to treat the animals with a selective treatment following the category, because in the sheep, honestly, it's really difficult to perform the selective treatment using the fecal egg count individually. I would like to know your opinion about this topic. Thank you.
Okay. Vincenzo Veneziano for Naples asks if selective treatment can be done also in sheep, because in different category, because he performed in horses individually. It's well known, but it says if there are any problems with several categories in sheep.
Yes, first of all, my response is, of course, the horses are something different. The horses are simple. You have a horse, several horses, you know, not 200-300 horses, of course, in the flocks. So it's much different. As I said, I would not go, you know, you can do like this, for example, that not to treat all the flock, for example, because some veterinarians trying to do, just those who have diarrhea, Diarrhea do not means that you have a very high fecal counts. Sometimes, sometimes not. So, but still, the main approach of this is to minimize the treatment, just to minimize, you know. So not to use 300 on 300, for example, the animals, but just 100. So you keep 200 heads in your herds, in your flock, untreated, you know. But you know, this attitude, it's probably good adopted in countries where they very high resistance, you know. I would go for another options. I would go not for targeted selected treatment, which is of course good, you know. It helps, but on the scientific point, of course, it helps. But for example, in people in Moredan, they did the long time experiment when they compared the fecal counts, because they are researchers, they are scientists. They made 100 or I don't know how many, but many of the sheep fecal counts, that selected those with the highest and range, minimize 70% of the treatment. They doing the same several years, and they compared with the flock they used prophylactic treatment. If they are look again after several years, of course, in a group where they minimize the treatment, it was much lower prevalence of resistant genes in these populations which are on this farm compared to those which are treated every time with all the animals. Okay, it's difficult. It's very difficult to adopt this kind of the attitude, targeted selected treatment. I would say for another one, go look on the pasture. Is there fence? If possible, of course. If you go to the England, it's almost nobody has possible to change the pasture, to rotate pasture, because everything is private. I have here 200 sheep and it's mine, and I'm keeping this all the year. Such kind of situation, it's resistant within several years. But if you have a chance to change, to rotate this, to do this, because it's minimizing your infection, your parasite infection. Because in Slovakia, why I was talking about 10% of benzimidazole resistance. In Slovakia, many of the farmers, majority, I don't know how majority, 70%, I don't know exactly, still adopted and still using this rotation technique. And according to me, this is the key factor why we have just 10% of benzimidazole resistance on these farms, in sheep farms. So this is much more important than adopt the targeted selected treatment. The targeted selected treatment is expensive. You know, so I hope you were satisfied, Vincenzo, because
we have a question from the floor from Thailand. Greetings from Thailand. Even thought the goats were raised strictly in the pen, we have faced anthelmintic resistance in them. Does this imply that a parasite is present in the feed that farmers deliver to them? Is there a way to treat all the grass or plant before distributing it to the animals? If you wanted to read again. Yes.
I'm not sure if I catch the point.
Yeah.
Very small. If I understand properly, the question is, does this imply that the parasite is present in the feed that farmers deliver to the dam? I mean the feed. What does it mean feed? I think the hay, probably hay. It could, some of them, of course, some the third stage larvae survive in a hay, but only very small minority. So normally, and we are having during the last 10 years many experiments, indoor experiments, and we are feeding the animals with the hay. Of course, it's indoor, not only concentrate, but just also the hay. And we didn't measure some infection from the hay to the animals. So the risk is minimal. It's minimal risk that you are feeding the animals with the feed, which is infected with some third stage larvae. Is there a way to treat or pour the grass or plant before distributing to the animals?
Is there any treatment to decrease the level of contamination with parasite, with larvae?
I mean, if I am to treat the grass, yes, or maybe to treat the pasture, because on a pasture there is third stage larvae, you know, so infectivity is from pasture. So, for example, in United States, they are selling apparatus with a small car, which is collecting fecal samples in a horse paddock. It's very simple, maybe a little bit expensive, so but it's collecting, you know, and then in this way you are minimizing the infectivity of the pasture, but this is not possible, of course, in a sheep or in a goat, because the fecal material is we are talking about different things. Okay, so I think you know, it's possible, but it still needs some future scientific future to test. You know, I don't want to talk more about this.
There is another question from
May I ask you a question?
Franco. Thanks for your presentation. I would like to know how is the true impact of a refugia for decreased of anthelmintic resistance. Many studies, but few applicable in practice.
Yes, I agree. But it's not only with refugia. It's with some different things. Not only refugia. It's people are talking about the refugia, but nobody testing. I know just one of these. I mentioned this. This is a study from Moredan from the United Kingdom, where I just mentioned this. I will not repeat this, but they are really comparing, minimizing the treatment in one group and do the prophylactic treatment in other groups. And several years, one by year, they genotyped also the groups of these two groups, and they find out. Of course, it was the real strict evidence that it's working, but these studies is very low. I know just one, but it's working. Of course, it's working. But
we have another sorry.
May I ask a question?
Yes.
I'm Giuseppino Cocco.
Ciao Pino.
I work as a freelancer in dairy sheep farms, and one of the problems is, as you underline, is the underdose of anthelmintics, and in spite we tell the farmers that they have to take into account the heaviest animals during the dose of the drug. It's not easy because you show, for instance, a very nice scale in one of your slides, but it's not easy for the farmers to have a scale because in Sardinia farms are not concentrated. Many times they have different pastures in different locations, and so under a practical point of view, I'm wondering, how could you assess the weight of the animal in order to use the right dose and avoid one of the problems that leads to the anthelmintic resistance? Thank you.
Thank you very much for your question. So it's about the weighing of animals. You know, so I guess I was in the farms many times where they try to treat the animals based of the heaviest animal in the flock. Of course, it's just a farmer or veterinarian should point to these several of the animals which is based of the eye. It's looks like most heavier, and then just measure the weight of these three animals, set up the drenching gun, and then treat all of them. Okay, it's you are using the overdose, let's say 10, 15, 20%, but it's still better than that you underdose 15, 20%. So it's I think the farmers are clever people. I think also the veterinarians, they should really estimate the heaviest, the members heaviest, for example, sheep in the flock. That's my experience.
Okay, thank you very much indeed.
Abbiamo un'altra domanda al professor Scala.
Io ero curioso di sapere, perché non ho capito bene, quale praticamente dosaggio viene fatto quando viene ripetuto il trattamento dopo 12 ore. Cioè viene fatto il dosaggio a metà del dosaggio normale e poi ripetuto a 12 ore, oppure sono due dosaggi pieni fatti a distanza di 12 ore?
He asked about the repeated treatment within 12 hours. And he asked if the dose of anthelmintic is full both times, or it was half. So half, and no, then second time.
Yes, it was the recommended. So it's the full dose, because it was comparing with the double dose. Okay, that using a double dose is not the same if you are using the full dose and after 12 hours full dose. So it just don't do the double dose, because it's a concentration going up and going down very quickly. So it's full dose. Yeah.
Sono rimasto molto meravigliato degli alti livelli di UPG che nei grafici che hai presentato vedo sempre livelli 1000 UPG, 2000 UPG, 5000 UPG. Noi qua in Sardegna, se vediamo livelli, cioè non li vediamo quei livelli di UPG perché le pecore sono morte. Che cosa, quale c'è una differenza di razza secondo te riguardo le pecore, o una composizione dei parassiti così diversa che giustifica questi livelli così elevati di UPG?
Professor Scala says that he was very surprised by your presentation, because you can be seen graphics with 1,000, 2,000, 3,000 OPG. And this is very amazing for Sardinia, because we normally, if we go over these levels, normally sheep are dead. So how do you explain this? He asked about the parasitofauna, if or of breed that are more adapted, because for us it's very, very strange to see such high levels.
as I mentioned in the presentation, it's Haemonchus contortus. So it's Haemonchus contortus experimental infection when these level, 15, 20,000, up to 30,000, it's quite common. Of course, if we are going to the field in Slovakia, we have also average 200, 300, 700. You see, I saw the two pictures. One farm, it was 150 on the end of the grazing season, average, and another one was 700, and it was really high, 700, you know. So it's, of course, the variation, but also in our cases, if we are talking about goats, it's higher, but in a sheep, it's also few animals have 1,000-2,000, another it's few hundreds, some of them was below 100, you know. So it's the same situation like you have in Sardinia, but of course, this is experimental infection with Haemonchus contortus, which is quite different, you know. So it's, of course, animals, lambs have anemia a little bit because it's a few hundreds or up to 1,000 worms which are in abomasum and sucking blood, of course, but they really very easily survive this infection. Okay.
Ci sono altre domande? Allora, qua, here we have congratulations for nice and fruitful presentation. All the best from colleagues actually in Poland. It's Patrick Bomb, probably knows you. So I think that we can close this webinar. I already thank you. Oh, just the last one. What additional herbs would you suggest to cure small animals, small ruminants? In practical terms, how frequently should a farmer combine with hay or feed? Is the same of before from Thailand?
Yes. It's really difficult to say which kind of the herbs we can use. I showed a few of them, either individually or combining. So the efficacy was something with 7, 8%, 9%, up to 50%. Okay. So I am not commenting the last two graphs, which was really 98, 99% of reduction. But in a meadow, in the pasture, it was up to 80 different herbs, you know, so it's a lot. So it's, I will not recommend because we still need to work on it a lot, you know. So of course the chicory is it's quite common. We had of course, it was not affect only chicory, but chicory is quite a good one. So, you know, we seed the chicory to this experimental field. It was very good 2 years. It was growing first and also the second year in Slovakia. And also the weight gain was very nice, you know, so it was, you can try. The chicory was tested, you know, also not only in our laboratory, but also in different places in the world.
Thank you. I think that we can close this webinar. Thank you again, Marian, for being here with us. I skipped to Italian. Volevo ringraziare ancora il professor Varady, è stato qui con noi, sono stati qua con noi una decina di giorni, è stato un tempo molto interessante perché a parte questa parte di docenza abbiamo sviluppato una serie di collaborazioni, soprattutto per quanto riguarda il laboratorio. Quindi io ringrazio tutti quanti, voi per primi che avete presenziato a questo webinar. Vi ricordo che sulla pagina YouTube del canale Parassitologia, quindi youtube.com/parassitologia, sarà possibile rivedere da adesso il video. Fra l'altro si vede molto meglio che su Zoom, mi dispiace, ma la tecnologia è questa, e ci sono anche i sottotitoli, quindi questo per chi avesse avuto qualche difficoltà con l'inglese ci sono i sottotitoli. Io ringrazio ancora una volta il Dipartimento di Medicina Veterinaria, la SIPAOC e la SOIPA per aver patrocinato questo evento, e grazie ancora a te, Marian, per aver partecipato, averci omaggiato della tua presenza. Grazie ancora.
Grazie a me.
Arrivederci.
Arrivederci.
Arrivederci.